this presentation is titled Make Your Ansible Playbooks Flexible, Maintainable, and Scalable. And I made this presentation just for this year's AnsibleFest in Austin. I'm glad to be back here. I was here for DrupalCon a few years ago and gave a good session on using Ansible with Drupal. And this presentation is not focused on Drupal, it's focused on Ansible, of course. And a little bit about me. I work for a company called Acquia. We are a digital marketing, hosting, amazing company in Boston. We have offices in many places around the world, and we help many of the world's largest brands have all of their digital marketing experience be hosted on the cloud securely, safely, reliably. I'm also a developer. I actually started out as a developer, didn't do as much infrastructure work early on, but as I was developing, I found that if you can have good infrastructure as part of your development and have kind of the DevOps ideals of making sure that you're integrating your code with production frequently and all that kind of stuff. As time went on, I switched more from being a developer to being a developer and somewhat sysadmin to now being what I would call a DevOps practitioner type person who still does some development work, but does a lot more infrastructure automation work. I also am an author. I wrote the book that you see here on the screen. It's called Ansible for DevOps. And I actually started writing the book soon after I learned about Ansible, because at the time there was no formal documentation outside of the Ansible documentation. And I really learned by seeing other people's examples, reading through how they did things, that kind of thing. And there wasn't much of that. There were some blog posts, but I decided to start compiling some of the things I learned into a book. And I published 3 chapters with the goal of having about 100 sales maybe having 100 pages, something like that. Before I even got halfway finished writing the book, I had over 500 sales and I had over 200 pages. So the book is still being updated. I published the first full version of it in 2015. And since then I've published 16 major revisions of it. I usually publish a major revision every time there's a new Ansible release, so 2.0, 2.1, 2.2, every time there's a new release I'll update everything. I also keep adding new content. So a couple weeks ago I added a chapter on Docker and a chapter on Kubernetes. And I'm working on finishing up a chapter on Ansible and HTTPS. So if you are interested in learning about Ansible and you're new to Ansible, it's a great book. If you're interested in learning about Ansible and new features in Ansible, and you've already used Ansible a lot, it's still a great book because I keep adding to it. That's one reason I love writing it, is because I can keep making it better, just like my software. Finally, I'm also a photographer. Before I became a full-time developer, I actually did a lot of event photography, did weddings, did things like that. So the picture on the cover of the book, pictures you'll see throughout this presentation, I took all of them, and I really enjoy photography. And I'll talk a little bit about how I can automate some of my photography as well with Ansible. So the first project I wanted to talk about that I'm working on, earlier I mentioned in 2013, I started working on converting some shell scripts to something automated, something more centralized. And that was for this project, Hosted Apache Solr. Hosted Apache Solr is a service I started in 2008, so this was the 10-year anniversary of that service. I'm proud to say that in that time, as measured by pingdom and server check-in, Hosted Apache Solr across all of its servers has had over 99.99% uptime. Pretty good for a guy who runs it basically on the side. And I have a few hundred clients at this point. One of the early challenges is I had one massive server and I kept scaling it up, but A, that's not good for reliability, B, that's not good for scalability, especially once you get past 10, 20, 30 clients. So I really need the Ansible to take my shell scripts and things like that and expand them to be able to run many servers, manage all the servers, do updates, preserve the data, do backups, all that kind of stuff. So at this point I have Ansible running with a containerized infrastructure. The evolution of the architecture of the infrastructure has been an interesting journey. I blog about it sometimes. If you go to jeffgeerling.com, you can search for Hosted Solr and see a lot of blog posts about it. But the reason I mention this project is because it had a unique aspect of having a ton of legacy architecture, a ton of legacy decisions that make it hard to do certain things. But with Ansible, I've been able to modify that architecture piece by piece and do it very safely with very good rollouts, being able to do big sweeping changes that do it server by server or do it by batches of servers, that kind of thing. So that's one way that I use Ansible, is to be able to evolve a service over time. Another way that I use Ansible a lot is, you can see here, these are two of my laptops, the one that I'm presenting on, my MacBook Pro, and my Dell XPS 13 at my house. I do a lot of development, and I have multiple computers. So one thing that I needed to do, of course, is automate my computer setup, because you don't want to spend time twiddling with your configurations and managing your dot files and all that kind of stuff. So I have one project I run called MacDev Playbook, and it helps you set up your Mac as a development machine using Ansible. And so whenever I get a new laptop, instead of restoring from a backup, which takes hours and you have to sit there and wait for it and it's really boring and annoying, I just install Ansible, and then I run this playbook, and I have my config.yaml file that has a few configuration options in it. And within 5 or 10 minutes, it already is productive. I have all my dot files in place. I have the software packages I need, all that kind of stuff. I also run a project called Drupal VM, and it was another one of my earliest projects that I started working on with Ansible. And the problem there was I had a team of developers that I worked with. 2 of them were on Windows, 2 were on Mac, and 1 was on Linux. And we were developing a Drupal website, and Drupal can be extremely complicated if you want it to be, and can integrate with lots and lots of systems. And we had a pretty complex site, especially for the time in 2012, whenever that was, 2013. We had dependencies like Apache Solr and Varnish and Nginx and Apache, and even some weird mono-based .NET software stuff we had to integrate with. So every developer had to spend what was usually weeks getting things set up if you needed to develop a certain part of the Drupal app. I started working on building a VirtualBox configuration using shell scripts to set everything up. And that was nicer, but not great, especially since the bash started getting really complicated. And one of the worst things was, once you set it up, it was kind of a snowflake. You couldn't really reset it or do anything like that. It was kind of a one-shot thing. So Ansible let me start to formalize that configuration and make it repeatable and make it updatable. If a developer changed a setting, they could revert it quickly using Ansible. So that grew into a very big project today that's used by lots and lots of developers to be able to manage their Drupal installation locally with tons of extra configuration options. It's kind of, I compare it, if you just want to run the Docker PHP container, that's kind of like a Porsche or something. Drupal VM is like the 18-wheeler rig that's carrying all your stuff down with it. It's very big and powerful, but it can take a little bit longer to get moving. But both of these projects, the reason I mention them is because I have to deal with, when I make changes to them, I want to make sure that I can make the change in a way that won't break everybody's local builds. So I have to worry about stability, I have to worry about releases, I have to worry about when I update 25 roles, am I going to break everything? I have basically an informal contract with all my developers that I'm going to help them not have to redo their whole world every month or something. So these are big projects for me, a lot of fun. I use them for my own stuff, so it's fun to be able to contribute them back. The final thing I wanted to talk about is a large-scale e-commerce platform that we run at Acquia. This is the project that I'm currently working on. It's a very large project that involves hundreds of e-commerce stores which have to deal with large-scale traffic events. For instance, there are some people who have these sites attached to their names that have millions of followers on Twitter and Instagram, and they will tweet and post photos and things and link to the store, and we'll have to deal with huge influx of traffic, huge order volumes that go up. So we have to have infrastructure that's scalable. Everything is automated, backups and building new servers and upgrades and fleet changes, and all kinds of things, swapping in and out different kinds of software. And Ansible has really helped us to make sure that every single process is automated, and not only automated, but easy to maintain. Any of our developers can easily get in there and make changes when we need to, rebuild servers as needed, that kind of stuff. Here's some of the things that I learned from even the Ansible roles that I maintain on Galaxy. A lot of them have taught me lessons about these kind of things, because for each role I have at least one test playbook that I have to maintain that integrates with Ansible and runs on every commit that I make to them. They also all run on a cron basis, so every week they're running. So I want to make sure that I'm doing things that make it easy for me to maintain them and easy for me to be able to compose them, put them together in different ways. And the 3 lessons that I've learned over time are: make sure you're organized, make sure you test everything, and make sure that it's as simple and optimized as it can be. And it's in that order too. You want to make sure that it's organized first before you start worrying about testing and optimizing and all that kind of stuff. And then testing is the most important thing after that, because you don't want things to break, and the best way to guarantee that is if you have automated tests. And finally, once you have all those things in place, it's time to start optimizing, make things better. You can't make things better until you know what's bad. Now, the first topic I want to talk about is organization. On the screen you can see a picture of the organization bins I have next to my little Raspberry Pi workstation. So earlier I mentioned I'm a photographer. One of the things I like to do is automate time-lapse photography and timed photography, things like that. So I have a number of Raspberry Pis. You can see some of the A+s here. I have a number of Raspberry Pi Model 3Bs, some Model 3B Plus, Model 2, Model 1, all these Raspberry Pis all over the place, some zeros and things. And I have a lot of them connected to cameras and sensors and things like that. And whenever I start a new project, if I didn't have an organization system like this, it would take a very long time. A lot of people I know, you just have a big drawer or box full of junk. It takes a long time to find the parts you need. A lot of times you also do things like you have 2, you go and buy something because you don't know you have one of them, and then now you have 2 of them, so you have a bigger mess to clean up and more stuff to manage. The same thing can happen in your Ansible playbooks. So the most important thing, it's not breaking stuff and fixing stuff, as it says here. The most important thing is to use version control. And this is something I do even if I'm not going to share a playbook with anyone else, even if I'm not going to put it up on GitHub or Bitbucket or wherever. I still use a playbook, or I still use a repository for every single project that I start. And the reason for that is I have a principle in my development of, it's kind of the agile philosophy of favoring working code over perfection or perfect code, that kind of thing. Architectural purity. The first goal that I have in every project is to make something that works, and hopefully quickly. You get something up and running, being able to connect to the server and install a package, boom, you have something that works. It might not be great, but it might work. So once I have something that works, I say git init, that creates a new repository. I say git commit, and then I say like initial commit or first build that worked, something like that. Then I start adding features and adding changes and things like that. Every time I make a change, I commit that change, even if it's just a local project that I'm just working on myself. That way I know points in time in my project when I can go back to that we're a known good state. And if I do bad things, I can say get reset head, get right back to the state that I knew that was working. So that's the first thing. Everything has to be in version control. No excuses not to. Another thing is, if it ever is going to touch anything in production, it should always be run from the build server. This was something that early on there weren't a whole lot of great options. A lot of people would use Jenkins, or a lot of people would use some random CI tool that they'd kind of hack in, get it working with Ansible. But I see a lot more tools out there. Like, for instance, Tower is very mature now, Ansible Tower. And there's also an open source version that was open sourced at last year's AnsibleFest called AWX. And those are kind of the premier tools for running Ansible playbooks in a CI/CD environment. And they let you do things like let anyone in the business who has access rights be able to run the playbooks that they need to run. The point of this all is, it doesn't matter if it's that or Jenkins or something else. I'm sure that Red Hat would prefer that it's Ansible Tower. But it doesn't matter what kind of build server. The point is that The build server is a consistent environment that tracks every change that you make to a production server. If you let developers be able to run builds from their own workstations, you won't have any centralized tracking of it. Another problem that I see a lot of times is developers can have environment variables that are different. Like let's say they have a couple different sets of AWS access keys and there's a task that does something inside of AWS. And if you don't have it set up the right way, maybe they accidentally screw up one of your Ansible or one of your AWS resources. That's something I've seen happen before. So making sure that everything runs from the build server guarantees that you have a consistent environment where your playbooks run and a consistent set of system state. Another big thing for organization is, I like to say, if it's important, it will be forgotten. The reason I say that is every repository that I make, if it's a quick little playbook for testing or something, maybe not, but every project I make, no matter how small, if it's something that's just doing a little upgrade or just doing a deployment a couple times or something like that, I always add a Readme file in that repository that I create. And the Readme always has these three things in it. First thing is a purpose. Maybe it's just a sentence or half a sentence that says what it does, like upgrades all servers to the latest version of X. The second thing is links. So if there are any resources associated with this project, like a Jira project or a build that runs in CI or documentation or anything like that, a list of links. And then also the third thing that's most important, especially as your project is shared with more people, is instructions for getting things running locally for testing. So one of the things that I'll talk about in a little bit with testing is how important it is to have good tests that are running. But it's important to be able to build the infrastructure locally as much as possible. There are some kinds of playbooks that are very difficult to do that with, especially in like networking, sometimes Windows, or when you're working with more proprietary licensed software. But you want to have instructions for how a developer can clone this repository, get something set up local, and start hacking on it right away. Just like when you're developing Ansible code, if you want to contribute to the Ansible project, there are instructions for clone the repository, run these commands, and then you can start hacking on Ansible's core code and add your own modules, do all kinds of crazy things, test patches, whatever. So those are the three things that I like to see in every README. Another thing I do when I'm organizing my playbooks is I usually start out a playbook as just one file. It keeps it nice and simple, especially when you're getting started on a playbook. Some playbooks don't ever go beyond that. You might have all the variables in your vars. You might have all the tasks in your task, and you might be done. Those playbooks exist in many places, and that's great. But once I start hitting around 100 lines in that YAML file, at least for me, and I'm sure for many of you too, you can't really hold what's going on in the playbook in your head anymore. And things start getting a little bit more complicated, especially if you're doing things like tracking some state or adding conditionals. So once I hit that amount of code in my Ansible playbook, I'll start splitting things out. So I'll look at related tasks. Like let's say you're installing a web server. You're going to install it with the package module. You're going to copy a configuration with the template module. You're going to add a handler that restarts it once that template file is copied. You'll notify that handler. The handler restarts the service. So there's 3 tasks there that are very much related, and they all have to do with the same kind of software. So I'll stick those into an include file. So you start breaking things out into include files with related tasks, and then your playbook gets back to a nice little small state again. It's very nice. You can kind of reason what's going on all in one little file. But then the next thing that happens is you start getting more complicated. You might notice that you have like a handler, 5 or 6 variables, 7 or 8 tasks. All these different things are related to one piece of software. And at that point, what I do is I take those out and put it into a role. And roles are ways of encapsulating one set of configuration, one set of state for what I usually do is one piece of software like Apache or Nginx or MySQL or MariaDB or whatever it is. Put all those into one role, and then you can use that role in one or more playbooks to configure that same piece of software. And with the roles, once you start putting things into roles, you can have one role has handlers and tests and templates and files that all are related to each other. You can make them more generic. So in my current position at Acquia, we have maybe 10 or 20 different kinds of server types. 5 or 10 of them need to have Apache installed, but each one needs a slightly different configuration. So what we did was we have one Apache role, and it can allow for different configurations by making the role a little bit more generic. And then another thing that you can do once you make a generic role is you can have the same role used in multiple projects. One way of doing that is copying and pasting it, but the problem is that when one project makes a change, the other one doesn't see that change. So the other thing that we do with our roles is each role goes into its own repository. And if we really want to go pro, we will generalize everything, put it under an open source license, and contribute it to Ansible Galaxy. This actually gives us a couple more advantages too, because now other people can use the role, other people can give us feedback on how to make it better. Ansible Galaxy can integrate its own testing and functionality to help us determine, like, is this a good quality role or not. There's actually some cool improvements coming to Ansible Galaxy that will automatically do some code analysis and give a quality review of the code. So you get a lot of benefits from contributing roles publicly, but even if you don't, it's nice to have each role in its own separate repository. That way you can also add tests for each role's repository, that kind of thing, and make sure that your roles are really solid, because then once you get to that level, you can start composing your servers and your services a lot more easily, because you just say, hey, I need a web server with a database and a key value store. So, okay, I'm going to grab my Apache, my MySQL, and my Redis roles, put them together, boom, I have that server ready. And you can do that with any kind of setup, whether it's LAMP or LEMP, or it's, what is the Node.js one? Whatever the Node.js and Mongo and all that. All these different server types, you can just stick them together with the roles that you build. Another thing about roles is once you have these roles, a best practice is to use versions for the roles. And I like to use semantic versioning because it's a way of identifying, like if you have a 1.something role, the 1. Series shouldn't ever break. If somebody uses 1.0 or 1.5 or 1.7 or any of those, nothing should break if they just upgrade to the next version of the role. You can add new features in 1.1, 1.2, 1.3, but the way that works is it gives an indication to the people who use your roles of when there are big changes that they might need to change things in their playbooks to use it. So every time that I update a role, I give it a new version. And if it's major changes, I'll increment the major version. So you can see on this list here, I have an Apache role that's at version 3, and a Drush role that's at version 3. That means 3 times in the history of the role, I made changes that were drastic enough to make people have to go in and change things in their own playbooks to be able to keep using the role. So anyway, the reason that's good is you can tell Ansible Galaxy using a file called requirements.yaml. You can put in one of these files. You can say, I need these roles, so I need to run Apache, and I need to run Drupal, and I need to run Git, and these things. And you can give it a version, and if you give it the version, then every time that you download the Ansible roles, there will be the exact same version of Ansible role that you did the last time that you built this, and it was in a known good working state. A lot of people will put in roles without a version. What can happen is, let's say you started this playbook back when my geerlingguy.apache role was version 2.2. When I upgraded to 3.0, that means there might be a new variable or a changed variable that could break something in your code, so you need to read the changelog. But if you just ran the playbook again and updated all your roles, it would pull the latest version because there was no version associated. So it's best practice to always put your versions in the requirements YAML file. One other thing that sometimes is good, but I generally don't recommend it, I recommend you put all these roles that are downloaded with Galaxy into a gitignore file. That means that they won't be put into your actual code repository. And then you have your build server download the roles every time that it runs the playbook. The reason for that is it keeps you honest. You can't download the Apache role and then hack it. And the next time somebody updates the role, your hacks are gone. It forces you to be honest with how you're using dependencies in your software. But there are some times that I do commit the roles to the repository. For instance, with Drupal VM, It's used by lots of developers all over the world, some of whom have very slow internet connections or flaky internet connections. And when there's a lot of roles being downloaded, if there's a failure 1 in every 20 roles, that means almost every time they update the playbook and run Ansible Galaxy install, they would hit an error. So I put all the roles into the repository to save them the time, to save Ansible Galaxy from having to serve up, hundreds of thousands of role downloads every day. And sometimes that can be a good idea. But typically I recommend not committing the roles to the repository code, because that's why you have the code separate, and then Ansible Galaxy can pull it all in. The next part I want to spend some time on is testing. So here's a picture of a stack of Raspberry Pis. This particular stack is in my house on my desk in my basement. It is called the Raspberry Pi Dramble. And the reason it's called a Dramble is because a bramble is a cluster of Raspberry Pis, kind of like a cluster of raspberries. And the Dramble is a cluster of Raspberry Pis that runs Drupal. So it's a Drupal bramble, so it's a Dramble. There's another definition online for Dramble, but don't worry about that one. This is the Dramble, and it runs Drupal 8, and I've used it for testing clustered Drupal setups. So in the past, there are some really nice things that I was able to test on it that I couldn't do with a traditional VM setup on my computer. For instance, there was a module that would have a bug, but it would only happen if your disk I/O was slow. And guess what? The Raspberry Pi has really slow disk I/O because it runs on a micro SD card. So I could reproduce this problem very reliably on the Raspberry Pis. So I used them to test and fix that problem. This particular cluster is now running Kubernetes, and there's actually, if you go to pidramble.com, pidramble.com, you'll be hitting the server that's running on my desk at home at this moment. And it's running on Kubernetes. The code for it is all linked from that website. It's all open source. If you want to build your own, I have instructions, links to all the parts and everything. Anyways, it's a nice cluster of Raspberry Pis that I use for testing with Drupal and clustering. And it's important for Ansible, too, to have the same kind of test coverage. And I have what I call the Ansible CI spectrum. And that CI means continuous integration. So it's the different things that you can do to test your Ansible playbooks. And I like to say that it starts with YAML-int and it ends with building an entirely separate parallel infrastructure, kind of a blue-green deployment. And not every playbook needs to do everything in this list. There's a lot of playbooks that I have where all I do is I check the syntax and say, oh, it's going to work if I run it. It might not actually do the thing I want it to do, but at least it will run because it's valid. So that's starting at the top of the list. YAML-int will just make sure that your YAML files will compile, basically. Ansible playbook syntax check is the next test that I usually add to my automated testing. And that one will basically look at all the syntax in your playbook and say, would Ansible run this if Ansible playbook were run? Yes. That doesn't mean that it'll work. It doesn't mean you won't fail. It just means that it would work. And that's a very quick check to do. And then on another level, there's Ansible lint. Ansible lint will actually look at each of the tasks in your playbook and say, is this doing anything stupid? Is this going to break? Is this doing anything that could cause problems? And it'll give you that list of issues. And then those three are kind of really fast to run. They only take a couple seconds total. And they give you a lot of value in terms of immediate feedback. So a lot of times people will put in a get pre-commit hook. That means anytime a developer says git commit and tries to commit something, it would run those. A lot of people put those in because that way it says like, hey, before you commit this, did you know that you're going to break everything? So those are really nice to have there. It's also good to have those as the first tests in your CI testing suite. So whenever you check in a commit to a playbook or you file a pull request on GitHub, run those things, make sure there's no simple problems. The next test is Molecule. In the past, I've actually used a lot of different systems for testing my playbooks, but Molecule has become kind of a community de facto standard. And in fact, Ansible just announced last week that they're going to adopt Molecule and make it an official Ansible project. So I use Molecule to run functional tests, integration tests on my playbooks. what it does is it will bring up a virtual machine, whether it be like an Amazon EC2 instance, or a VirtualBox virtual machine, or a Docker container, whatever kind of environment you want. It brings it up, and then it puts Ansible inside of it, and then it runs your playbook inside that environment. There's a lot of configuration with it. It's also something that's a little bit, the documentation could use some improvement and things like that. But the point is that it's running your entire playbook in a fresh environment, and you can repeat it. You can have it run over and over again, and you can let your developers use it on their local machines. It's very nice. And I'm prepping some content for a new section on Molecule in my book as well. So if you buy the book, you'll get that. After that, there's another thing that you can do. This works if your CI server has access to your production servers, which not all of them do, so that's why I have this towards the end of the list, because not everybody's going to be able to do this. But you can have your playbook run with check mode. And check mode basically says, run the playbook, but don't change anything. Just show what would have changed or what would have happened. And this is really helpful for things like compliance, like if you need to make sure that nobody's changed any files on your server, have your playbook run every 10 minutes or every hour, or every day or something like that. Have it report if there's ever any changes noticed, because that's the whole point of Ansible, is to be able to say, run my playbook one time or a million times. First time it should change everything. Every other time it should just say, nothing's changed, everything's good. So running your playbook in check mode is helpful. And even if you can integrate it with your development process, after you finish developing a new feature, you can run it in check mode, say, hey, this only changed the two things that I thought it would change. Okay, we're all good. And if it changes anything else, hey, something went wrong. The last thing on the list, which is more rare, I don't see it too often, and I actually don't have any infrastructure right now that is tested this way, but you can build a blue-green environment using Ansible. So when you finish committing something or you have something ready for release, you would build parallel to production, another production environment. Once all the system tests pass there, you would cut over to that one, and then delete the old production infrastructure. That's something that's a little more specialized. I'm not going to talk too much about it in this presentation. Some more tips for testing. Whenever you run an Ansible playbook, at the top it'll give you any deprecation warnings. Those are things that are changed in Ansible that you might want to take heed of and fix. Whenever I see one of these, I'll immediately file an issue in our backlog. And you usually have at least 6 months to a year, usually longer, before the deprecation warning becomes broken code. But it's good to heed those and make sure that you follow up on them and get rid of them. You can turn them off, in fact, if you want to, but I usually don't do that because it reminds me, hey, there's code in here that I need to update. Also, every time there's a new release of Ansible, they release a porting guide. So Ansible 2.6, 2.7. The porting guide has tons of great information about what's new in it, any changes that are made that you might need to update your code for. So read those, they're very good. Also, in line with the deprecation warnings, sometimes you see warnings in your playbook runs. And it might say like, hey, there's a yum module, don't run the command module and use yum. Sometimes you actually do need to run the yum module. If you do, you can use, you can set this warn no or warn false on your tasks that use command and shell and some other modules that Ansible might warn about. And you can turn off those warnings. It's nice to have a very clean playbook output without any warnings on it. Finally, for my testing, I always make sure that in my CI environment, I always have it running the latest version of Ansible. And the reason I do that is because that way we're always ready for the next release of Ansible, because right when it comes out, we start having our automated tests run on that release, and if something breaks, we know that in the next version of Ansible that we'll install on our build server, there's a breaking change. So we'll be able to change our code before it's too late and before we upgrade on the production build server and it blows things up. So I always use the latest version of Ansible on the CI server. That helps us keep our code up to date. It helps us it helps us see when there's deprecations quickly, because we usually only update our build servers quarterly to the latest version of Ansible, so they lag behind a little bit. Like right now we're running 2.5 and 2.6 is out, and we're scheduled to upgrade to 2.6 and 2.7 is about to be out. But it's good to be on the latest version as much as possible. You don't want to be in a situation where you're upgrading from Ansible 1.9 to 2.6 because there's too many changes to keep in your mind, and you're going to have major problems. So the last section I want to talk about is simplification and optimization. And the reason I have a picture of my AirPods is because I think of all the products I've seen in the past 10 or 15 years from Apple. Apple's a consumer company that makes very solid, if not expensive products, but the AirPods are the one product that I saw that it was like, these are just, you can't take away more and you can't add more. Like they're really good at what they do. They're expensive, but they're really good at what they do. And you can tell the engineers spent a lot of time stripping features off of things, like there's no cable between them. There's no extra buttons on the AirPods. The way that the pairing works and the way that the charging works, everything is just really honed in and it's really optimized, and it makes for a pleasant user experience. People that use the AirPods love them because they're so easy to use, they're so intuitive, and they work. Like there's a few cases where you wouldn't want to use them, but for running, for talking, for doing all kinds of things, they're a great product. And the exact opposite of that situation is when you see somebody trying to stuff programming into an Ansible playbook. And what I mean by that is, if you've ever seen a when condition in a task or anything where it's like 3 or 4 lines of Python with weird quoting and backslashes and all this kind of stuff, what I say is YAML is not a programming language. Don't try to program in your playbooks. If you ever have lots of Python code, or my principle is if I ever spend more than 10 minutes trying to figure out how to escape quotes in my YAML file, I know I'm doing something wrong, and it's probably time to start breaking something out into an Ansible module or plugin or something like that, so that I don't have to have this hacky Jinja to Python YAML mashup thing that is a monster, and I'll never be able to figure it out again once I get it working. Every now and then there can be some exceptions to that rule. And you can definitely use filters and things like that. But if you start doing really weird manipulations, you should consider writing a filter or writing a plugin or writing a module that does the things that you need to do so that your playbooks can just be YAML, a nice structured list of stuff. Another thing that I see a lot of times is somebody will have, this is a very simple dict where it's like Apache and you have some Apache configuration. But a lot of times the dictionary becomes very complicated. I prefer to have flat variables, meaning it's namespace, so I have Apache starts over with Apache Max clients, Apache whatever. Some variables you will need to use a dictionary, but I wouldn't put everything into one big dictionary. That creates some problems, like if you want to use it in multiple playbooks, any playbook that wants to update any option will have to overwrite that entire dict and have a lot of duplicated code, even if it's just one setting that they want to change. So that's one annoying thing. Also, it makes reasoning about what the variable is when you're looking at your vars and things like that. It's hard to see kind of a structure to how variables work if there's just a big blob of a dictionary. So usually I prefer flat variables like this instead of using a dict. Even though the dict looks really fancy and structured, it's hard to work with. Whoops, I hit the wrong button. Another thing that I keep in mind is developers hate waiting. There's an XKCD comic about it. What are you doing? You're playing with swords and things. Oh, the code's compiling. Developers, that might be fun the first day, but then you realize it's really boring waiting around for things. So when you check in a change to some infrastructure code, you don't want to wait 3 or 4 hours for it to build and let you know if it worked or not. I know some Java developers might differ there. They might love sitting there waiting 6 or 7 hours for everything to move around and dependencies to be shot everywhere. But CI is useless if it's really slow. So you want to make sure that your playbooks run fast. There's a few things you can do. So the rest of these are some tips that you can use in your playbooks to make them run a little faster. One thing is you can disable gather facts. A lot of times you don't need to have a lot of information about the systems you're running on. If you're not doing things like detecting what OS it's running or the memory requirements, things like that, you can just turn off this gather facts. It'll save a few seconds per server, and if you're doing a lot of servers, that's a lot of time that's saved. Also, when you're running with more than one server, check what you have your forks configured to do. Ansible will run on as many threads as it can with your forks configuration. And by default, I think it's 5. So if you're running a playbook on 25 servers, and you have enough memory on your system, your build server, to be able to run the same stuff on all 25 servers at the same time, you can speed up your playbook run by 5 times by just setting forks to 25 instead of 5. That way it can work on all the servers at the same time instead of doing it in batches of 5. Obviously there are situations that are different. You want to use the serial setting to run a playbook on batches of servers intentionally, but make sure you have forks configured so that you can use all the memory and resources of your build server when you're running playbooks. A lot of modules also have things that can, if you use it the wrong way, it can be way slower. So for instance, package. If you package or apt or yum or DNF, any of those package modules, you can actually pass a list, so you can have multiple packages and pass it straight into the name parameter. If you do that, then it can optimize it and run one command that will do all the operations on the packages. A lot of people use loops, and I still do this because early on I started doing it this way. But a lot of people use loops or with items or whatever to throw in packages. But what happens there is for every item, Ansible will create another Python module, throw it to the server, check on that package. When it's done, it does the next package, and it keeps having to use that connection, and it's really slow compared to everything at one time. Now the copy module. I had one playbook that, when we started building it, it took, 10 or 15 seconds total for the particular copy task. That wasn't too bad. But over time, we had a few hundred files in there. And what copy does is it goes through each file, and for each file, it sends it over the wire to the server instead of kind of doing it all using a more efficient format. And it doesn't do archival, so if you have large files, it's slower transport, all that kind of stuff. So copy is great for single files or small directories, but if you want to speed things up and you have lots of files or large files, that kind of thing, consider using the synchronize module or rsync or something else. Another one that I see a lot of times is people, line and file is great for making a couple changes to a file. But if you have 10 or 20 changes to make to a file, consider using a template and templating that file instead. Or using a block-in file if you have a block of changes to make. Both of those will make things a lot faster in your playbooks. One way you can quickly know which changes help the most is by profiling your playbook. And the easiest way to do that is using some Ansible callback plugins that are extremely handy. All you do is in the top here, you can see defaults callback whitelist. That's something that you can put into your ansible.config file. And anything you put in there, it will use those callback plugins when you run your playbook. And these particular callbacks that I list here, timer, profile tasks, and profile roles, they will give you a play-by-play or a task-by-task timer that shows how long each task took. And then at the end, it'll also give you a summary of how long each role took to apply and how long each of the individual tasks took to apply. So you can see on this one, my Docker role took almost 10 seconds to run. You can really see an outlier though. If you have a role that takes like a minute or 2 minutes, you might want to look into what is taking so long for that particular role. So that's a really nice way to profile your playbooks and find outliers that are really slow, that are slowing you down. Another thing, so these are, there's a few more things I wanted to talk about that are kind of like kitchen sink. One thing is with inventory. It can really, I would call it a code smell. Code smells are things that you notice in code that are not great and can be a sign of problems, underlying problems. And I would call checking in inventory file changes to be code smell. If you need to change your inventory, if you use a static inventory file and you change it, once or twice a month or something, that's too much to be changing it. You should probably think about using dynamic inventory. And it's really simple, but a lot of people don't think about it. If you have a static environment with, let's say the Raspberry Pis I had earlier, I have 5 Raspberry Pis, that's not going to change that much, if any, ever. So if it's a static environment like that, use a static inventory file. Or if it's just one server, that's fine, use a static inventory file. But if you have auto-scaling groups, or if you have servers that will change a lot, IP addresses that change and you need to use the IP to connect, that kind of thing, use a dynamic inventory. It's really easy to use if you haven't ever used dynamic inventory. Ansible has scripts for popular cloud providers to be able to do it. You can write your own. It's not that hard. That's what I use for hosted Apache Solr. There's an API endpoint that I use that spits out some JSON, and you can write it in any language. This is in PHP. You just spit out some JSON with the list of hosts and groups and any variables that go with those hosts and groups, and you're done. It's not that hard to do. So that's inventory. A few more things. Hopefully you've been learning this at this conference and as you start on your automation journey, but automation should be all or nothing. You shouldn't start automating but also still have manual processes. You should say, you know what, automation is the best way. We can accelerate our learning and our builds and everything by automating. Try not to let people log into servers and make changes manually, because A, that will make your tests fail if you're running in check mode. And B, that will make it so that you can't really scale that. You can scale Ansible playbooks massively, but you can't scale people logging in and doing things. Finally, be explicit. So I always like to define the state in my playbooks. So if I'm installing a package, the default is to say present, but I like putting state present because that really shows me I want these packages to be present, and it's codified in that playbook. What wants to happen. And finally, I mentioned a few other callback plugins for profiling, but there's also a bunch of other cool callback plugins that you can use. One of my favorites, if you've never tried it before, is the YAML callback plugin. By default, who here has ever seen an error message in Ansible and it's just lines and lines and lines with a bunch of new line characters in it? Completely unreadable. YAML takes that and it actually formats it for human consumption so you can read the error message. It's amazing. Anyways, I usually use that callback for all my playbooks and my CI and everything. So, going back to the beginning, these are the 3 lessons that I learned. I hope that you will pick them up and learn them as well. All the time that I've spent breaking things over the years hopefully has saved you a little time in not breaking things by using these lessons. Stay organized. Make sure your playbooks are organized, just like my organizing bins for my Raspberry Pi projects. Test everything early and often. Make sure everything is covered in tests. Use that CI spectrum. Simplify, optimize, make things fast. Developers will be happy. You'll be happy. You'll be rolling in cash. It's a great, great world out there. Thank you.